Okay, so question 7 finally. This was a little bit disappointing for me, I guess, because of time as well. People had to rush this rather than thinking about it. But calcium oxide, potassium fluoride, okay? These are both ionic substances. So people talking about all kinds of other intermolecular forces, just no, just stop, okay? Um, the thing that it's asking you to compare is the fact that the ions have different charges, and the fact that they have different charges means they have different sizes. Um, like you can see that, yeah, calcium and potassium are isoelectronic series, which means they both have the same number of electrons in their ionic forms. And so is fluorine and oxygen. So when they are ions, they have the same number of electrons. So the big difference is actually the ion size. Now we spoke about how the calcium, the higher the positive charge of an ion, the stronger its effective nuclear charge compared to the electrons it has, and therefore the smaller the ion. So the CaO can pack more tightly as a result of this factor, and therefore the Coulombic attraction, which is the distance between two charged particles, is smaller. Therefore, the strength of their interaction is larger. Remember, we did this in like midterm 1 in semester 1. I know it's been a while, but it is there, okay? So Coulomb's law. The closer together two charged particles, the stronger the attraction between them. The closer together two charged particles, the stronger the attraction between them. And it's basically saying that calcium and oxygen ions are able to pack better than potassium and fluorine are, okay? Now, for BI, this was done okay. I think the revision that we did on equations right at the end a couple of weeks ago was very useful for this. So calcium oxide, when you dissolve it in water, it will make a calcium hydroxide, an alkali hydroxide. Now, what is higher for this reaction, the bond energies of reactants or the bond energies of the product? You are releasing heat. So what that means is the bond energies of the product must be higher than the bond energies of the reactant. Remember, you have some bonds. You put energy in to break them. And then energy will be released when new bonds, like substance B, substance D, form. And you have to keep in mind that if it's exothermic, your product bond energies are higher. If it's exothermic, your bond energies in your products are higher. Because when products form, you release energy. When reactants break, you take in energy. It says that a lot of heat is given out. So you have to know that, okay? Now finally, what is the sign of delta S for this reaction? Well, you have a solid and a liquid becoming a solid, right? Calcium hydroxide. I mean, if you don't realize it's a solid, I suppose that might be why you got it wrong. But at the same time, I feel like most of you got the balanced equation right, but without getting the entropy question right. You're having a solid and a liquid becoming a single molecule of solid. So the entropy is negative, starting from more molecules becoming less molecules. Okay? So that's it for these questions. Hope it helps. Please let me know if you have any questions.